Okay, welcome back to Terence Payne Engineering. Okay, now what I want to do is to look at electrical power, and this is where I am looking at. Okay, electrical power unit 63. Okay, now never mind the year it was done. The knowledge is still relevant and still pertinent to this day. Okay, and will forever be pertinent. Now what I want to do is to look at calculating the resistance of coils, current, power factor, etc. Okay, right. Three coils are sorry, three coils each of resistance 12 ohms and reactance 9 ohms are connected in star to a three-phase 440 volts 50 hertz supply. So let me identify those information for you. Okay, here you are. Okay, you need to extract these. Okay, okay. Here's your frequency. Okay, 50 hertz. And here's your supply. What you need to calculate is calculate for this load A, the line current, B, the power factor, and C, the total power, D, the apparent power. Okay, and all of the things we need to take out and extract. Now I'm doing this as if I was doing it myself and working through my own calculation, but you find your own method of working, so that is your own style of learning. Okay, that is applicable to yourself. Okay, but this works for me, and I tend to put pen to paper. As I've told you already, don't try to learn it off the screen. Put pen to paper, write it out. Okay, so let us extract the what we know, or extract the relevant information. You can see here we have the resistance. Okay, and here we have the X for impedance. Okay, and here we have the voltage line. Okay, now how do we do A? Now we need to find the total impedance per phase of the circuit, and we do this by finding Z per phase. That gives us square root of R squared plus X squared equals 12 squared plus 9 squared, which equals 225. Now I'm surprised here that I didn't put in what 12 is. Okay, so I'm a little bit surprised here myself. 12 is what? 144, isn't it? Yeah, let me just check that for myself. I'm surprised that I didn't put that bit in. equal 144. Now what I would normally do here, okay, is just put this in. Okay, 1 4 4 plus sorry, let me just rub that out a little bit. Get back to my drawing. Plus, what's 9 squared? 81. Plus 81. Now when you add those up, that becomes this. Okay. Okay. And when you square root it, it gives you the answer here, 15 ohms. Okay. So what you need to do is to be able to know where each piece comes from and use the correct formula to arrive at the correct solution. Now remember, line current equals phase current, okay? Now let us find phase current. IP, current phase, equals VP over ZP. And here we have volt. We know VP because we have been given that in our formulation already. So let's look at that. That is part of what we have here, okay? And remember, line current equals phase current, okay? So let's find phase current. IP equals VP over ZP, okay? We've been given that in the question, 440, okay? Voltage phase. And we have to divide that by the square root of 3, which is 440 over 1.732. Now confirm that for yourself. Make sure that you understand how the square root of 3 is equal to 1.732, okay? That gives us 254 volts. Let me just circle him for you, okay? So you can see where I'm talking about, okay? Therefore, we now have the voltage. I current phase equals voltage phase over ZP equals 254 divided by 15, and you have 15 already. We know where the 15 comes from already, okay? Comes from here, okay? Comes from here, boom, boom, boom. I'm making it sparkling, okay? Okay, here we're putting on some cat whiskers on it, okay? Okay, therefore equals 16.93 amps. That is our current. Now this is power factor equals cos theta. I call it cos theta, you call it what you like, equals R over ZP equals 12 over 15 equals 0.8 lagging. Now make sure you know whether it is lagging or leading, okay? I'm going to leave that for you to find out yourself, because my interpretation as to how I look at it, you need to look at it from your own perspective, okay? To make sure you can determine that for yourself. Okay. Now total power, P equals square root of 3 times VL IL cos phi. And what I've done here, I've put, this is just how I work, okay? This is how I work, because I need to see where all my information is and where it's coming from. And that is 10,321 watts, 10.32 kilowatts. And that is my power here, okay? Now make sure that you can see how you got it. Now the pound power, S equals square root of 3 VLIL. And here you have pound power of 12.902 kilovolt amps. Okay. Now again, look at it from your perspective. Make sure you understand the concepts of it. Okay. Let me just go back up a little bit, make sure that I haven't missed anything out. Okay. Now electrical power unit 63. Okay, still on that. 3 similar choke coils are connected in star. Now, one of the things I noticed I haven't done here, I have not drawn you the diagrams of the circuits. Okay, so make sure you know what I'm talking about. So do your own research. There is enough electric principles books to tell you what a choke looks like and what choke coil also looks like. Draw a diagram to support your information. Okay, I did not draw a diagram here because I just didn't need it at the time. But looking back at it now, and as I'm trying to present it to you, I felt that a diagram might be more appropriate, would say a lot more words than I can put it into. Okay, so make sure you look at and draw out a diagram. If you cannot find one, I'm sure you can ask your lecturer. They would be willing to help you. Now, let me just go back to that. 3 similar choke coils are connected in star to a 3-phase supply. If the line currents are 15 amperes, the total power consumed is 11 kilowatts. And now hang on, let me pick these out. And the volt ampere input is 15 kilovolt amperes. Find the line and phase voltage. The reactive volt ampere input and the reactance and resistance of each coil. Draw a phasor diagram to show the line currents and voltages. Okay. Now, the first thing we need to do is to extract our information. What have we got? I can see 15 here for a start. Okay. What have I got? 11 kilovolts. I can see that here. Okay. So okay, it's just the pad preventing my hand from going in the right direction. And I can see we got something else here. Okay, let me just change a different color, a brighter color. Okay, and we got something else here. So okay. So all I'm doing is extracting my information from the information given. Okay, what else do I need? What else is there? What else have I been given? Okay, okay, and then I need to draw a diagram of the phasor. So, looking at this now, what we're looking at, power factor cos theta equals power P over volt amperes. And cos theta, we need to find whether it is leading or lagging, the angle. And we can see here that it is lagging by 0.73333. 0.733, yes, okay. Ah, hang on. Well, let me look back at my question again. And the three similar choke coils are connected in star. Okay, so I did draw a diagram that represented my star connection. Okay, and you can see here that these are the chokes. Okay, these are the chokes. These are each choke. A choke is a coil. Okay, choke is just simply a coil. Now, let me just get a different color. These here, the resistors, represent the internal resistance of the choke. Okay. Okay. Represent the internal resistance of the choke. Okay. And here, let me just go back up, make sure that we've got everything in play. Okay. I'm just recapping, okay, basically, okay. So just bear with me just to make sure that I haven't missed anything out due to my distraction and talking to something else. Okay, thank you. Okay. And here we are, okay, and we're back here, okay. Now here I've taken information from a guy called J.B. Prattley, and some of you may well know him, okay. Well, but he was big in my time, okay. That's the phasor diagram. Now, I would like your phasor diagram to be better than this, okay? Okay, your phasor diagram should be better than this, okay? Better than mine. Mine is hand-drawn and done quite rough, okay? In a star connected system, line voltage, VL, okay? And again, here we have your information that you will need. Use it, okay? Do not ignore it. And again, and here we have similar power. Our current line equals current R equals IY, IB equals IP. Okay. Now, three-phase colors are no longer red, yellow, blue. So please be aware that I'm using an old phasing system. I think they're now black, gray, and brown. But don't hold me to it. That is for you to check and double check, okay? Now here we have power, because we've been given this in the part of the question. Okay, we've been asked to find something. So what were we asked to find? Look back at the question, okay, make sure you understand the concept of it. And here we have to bring this down. I know that square root of 3 is 1.732, so what I've done simply is to transpose. Okay. Okay, voltage line, okay. and voltage line equals 577.39 volts. Okay, make sure you're happy how this was achieved. Okay, so that you know how we got it. Okay, and here we're looking at voltage phase. Okay, I don't need to do much talking now because you should be familiar with this. Practice, practice, practice. Okay. Now Q equals reactive volt ampere. Volt amps equal volt amperes input times sine theta. I call it theta. Okay. And this is my process here. Okay. Make sure that you're happy with the result. 10,200 volt amperes, 10.2 kilovolt amperes. Reactive. Okay. And that's it for me. I hope you find this useful. Okay. There's another part to this, but I haven't done that part yet. I've got it, but I don't know why it's not on here. But I'll see why, if I can give that at a later time. Okay. But thank you for your time. Have a good day, and I hope you have found this quite useful. Okay. Okay. Thank you. Bye bye.